All right, let's pull back the curtain on the silent, tireless manager that runs your entire digital life. We're talking, of course, about the operating system. We're going to demystify what's really going on inside your computer. I mean, think about it. You click an icon, you type on your keyboard, you move your mouse, and everything just works. But it's not magic. There's this incredibly powerful go-between making it all seem completely effortless. So what's the secret sauce here?
Well, it's the operating system, or just the OS. The best way to think about it is as the ultimate communication bridge. It stands right between you and your apps on one side, and all that complex raw computer hardware on the other. Honestly, without the OS, your computer is just a very, very expensive paperweight.
So let's think of the OS as the secret boss of your computer. It's this manager who's always working behind the scenes, making sure everything is running just right. It's the one calling the shots and, keeping the peace.
Okay, so what's its official job description? An operating system is the system software that manages, well, everything. All the hardware, all the other software, and it provides the stage for your applications to actually run. It really is the foundation that everything else is built on top of.
Now, this manager really has two main jobs. First, it's a resource arbitrator. It decides who gets what and for how long. It's divvying up CPU time, handing out memory, and controlling access to things like your printer. Second, it's a service provider. It gives all your programs a simple, standardized way to use the hardware without needing to know all the messy, nitty-gritty details.
So, how does this manager actually get the job done? Well, it oversees a few critical departments, and it's juggling a whole lot of responsibilities at once. Let's meet the team.
The OS management team basically has four key players. You've got process management, which is kind of like the traffic controller for all your running apps. Then there's memory management, which hands out temporary workspace to each program. Device management handles all your physical gadgets. And finally, file management acts as the master librarian for every piece of data you have.
Let's zoom in on memory management for a second. The OS here is like a super meticulous office manager. Every time a new program starts, it finds it an empty desk, a clean block of memory. But, and this is the crucial part, it also puts up little walls to make sure one program doesn't accidentally start writing all over another program's desk. That protection is absolutely critical for keeping your system stable.
And then there's file management. Your OS organizes everything in this neat tree-like structure, just like a physical filing cabinet. It all starts from one main drawer, the root directory, and then branches out into all your folders and files. This hierarchy is the only reason you can manage thousands, even millions of files without it being total chaos.
Okay, now for what is maybe the OS's most impressive magic trick, creating this incredible illusion that it's doing a million things at once. We all know it as multitasking. It just feels totally seamless, doesn't it? You're browsing the web, music's playing in the background, a file is downloading, but your computer doesn't actually have multiple brains. So how in the world does it pull this off with just one CPU or maybe a few cores?
The secret is this brilliant technique called time sharing. The OS slices up the CPU's attention into these incredibly small chunks of time. We're talking milliseconds or even faster. It gives one tiny slice to your music player, the next to your web browser, the next to your game, and it just cycles through them thousands, maybe millions of times per second. It happens so fast that to us, it feels like it's all happening at the same time.
Now, to manage all this, the OS acts as a scheduler, and there are two main styles. With preemptive scheduling, the OS is a proactive boss. It can literally interrupt a task if something more important comes along. But with non-preemptive scheduling, the OS is a bit more patient. It has to wait for a task to finish up or pause itself before it can give the CPU to another program. Let's actually see this in action. Take a look at these charts. On the left, we have a preemptive system. See how process P2 arrives and starts running, but after just 1 millisecond, bam, it gets interrupted, preempted, so that a shorter task, P3, can run. Now look at the right, the non-preemptive system. Once P2 gets the CPU, it's not letting go. It runs for its full 6 milliseconds, and everyone else just has to wait in line. This is exactly why almost all modern systems are preemptive. It just makes them feel way more responsive.
Okay, so we've met the manager and the department heads. Now it's time to step inside the CEO's office, because at the absolute heart of the operating system, we find its most critical component, the kernel.
The kernel is, well, it's the core of the core. It's the very first part of the OS to load up when you turn on your computer, and it's the absolute last thing to shut down. It has ultimate power and control over the entire system, handling the most fundamental jobs. To handle this immense power safely, the system has two distinct states or modes. When the kernel is running code, the computer is in kernel mode. Think of this as the CEO mode. It has unlimited, privileged access to everything. But all your other stuff, your browser, your games, your apps, they run in user mode. That's the employee state, where access is super restricted. They have to ask the kernel for permission to use resources, and this separation is absolutely essential for security and stability.
You should know, though, that not all kernels are built the same way. There are three main designs. You've got the monolithic kernel, like in Linux, which packs all its services into one big, fast program. Then there's the microkernel, which is the total opposite. It's tiny, and most services run outside of it as separate programs, which is more stable. And then you have hybrid kernels, like what Windows and Mac OS use, which try to get the best of both worlds. Here's a great way to make sense of that. Think of it like managing a city. A monolithic kernel is like a small town with one really fast mayor who runs everything directly. It's super efficient, but if the mayor's office has a problem, the whole town grinds to a halt. A microkernel, on the other hand, is like a massive metropolis. The mayor only handles basic communication, while a bunch of independent departments run everything else. It's way more stable, but that communication between departments can be a little bit slower.
And you know, that really is the perfect way to sum it all up. Your operating system is doing an absolutely incredible amount of work every single second you use your computer. It's juggling resources, it's managing memory, and it's creating that amazing illusion of multitasking. And the true genius of it all, when it's doing its job perfectly, you don't even know it's there.